Hi, we are Group 1. This is our IPCC AR6 final report, the suitable place for immigration. This is our outline. We will talk about the research motivation, the research method, the results and discussion, and the future outlook. So, we'll start with our research motivation. The climate change has always been a very serious issue and was proven real. The IPCC reports disclosed a lot of details of the future, and right now, we are standing at a point where every next step matters very much. We, Generation Z, plays a very crucial part in the climate change and the Earth's future. Which path we choose will significantly affect the world in 100 years. And since we're all in this together, this emergency of course caused some worries among the young people. So there is this word, climate anxiety. It's a solid example of the urgent need for action. Based on a research targets dozens of countries, more than tens of thousands of young people between 16 to 25. More than half of the participants expressed extreme concern or very high level of concern about the climate change. This finding highlights the magnitude of the emotional impact that climate change is having on our youth, who are witnessing the consequences of environmental degradation firsthand. And we can also see the proof of climate change. A lot of people keep saying that the temperature in summer in Taiwan is getting hotter and hotter every year. And the truth is, Taiwan was becoming hotter, but not so significantly. And under the different RCP models, Taiwan's temperature will rise in different degrees. If we choose to go with the RCP 2.6 path, we will only be hotter by 1 degree Celsius. But if we choose to go with RCP 8.5 model, the temperature in Taiwan will rise from between 3.0 degree to 3.6 degrees Celsius in the future. That means the temperature above 40 degrees will be normal in the summer. And from 2019, it's been 3 years since a typhoon actually landed in Taiwan. And by the future prediction, the amount of typhoon will be 50% less than right now, and the severe typhoon will be much more frequent than right now, along the wind speed and the rainfall. So, we've come to a question. Under the influence of the climate change, where is the most suitable place for us to live in the future? So, how can we find those places? We are using the IPCC AR6 report. This report is the most comprehensive assessment ever made of the climate change science to date. The report is able to identify vulnerable regions, and it focuses entirely on the science behind the climate change. It is the one that provides graphs and estimations from regions all across the globe. The synthesis report takes this data and some graphs as well in order to promote the policies and ideas. AR6 report is the most viable and trustworthy report to date. It was made by 234 scientists from 66 countries, built on more than 14,000 scientific papers. Its 3,949-page report is approved by 195 government officials. It used the most advanced modeling techniques, including AOGCMs, atmosphere ocean general circulation models, and ESMs, the Earth system models. And we've got to the third part, the results and discussion. As you can see in this graph, this is about long-term change of seasonal mean precipitation. The darker the green or the brown gets, that means the place will have more or less rainfall in the future. So the circle part are the places that will have fewer changes in the seasonal mean precipitation, like the Brazil Highlands, the Southeast Africa, the east part of Indian Peninsula, Southeast Asia, and North Australia. And the next graph is about the seasonal mean sea level pressure change. The more red it gets, that means the place will have higher sea level pressure. And on the other hand, the more blue it gets, that means the place will have lower sea level pressure. And the circle areas are the places that will have fewer changes in the atmosphere pressure at sea level, which are the east of North America, Brazil, the West Africa, the Southern Africa, and Northern Europe, all the way through Russia and Siberia, and finally the East Asia along the Pacific. And then this graph is projected spectral patterns of change in annual average near surface temperature. This graph talks about when the Earth increases exactly at 1.5 degree, how the different places' temperature will change. And as you can see, the whole globe is turning red. But there are still some places on land that will be less hotter than other places, like Argentina, Central Africa, Indian Peninsula through Southeast Asia Peninsula to east part of China, Taiwan of course, and the islands of Indonesia. And then this graph is similar to the previous graph, but the difference is the previous graph is under when the Earth increased 1.5 degree, but this graph is based on SSP 1 to 2.6 scenario. In 2081 to 2100, the estimated temperature change of the world. And as you can see, there are a small blue part in North Atlantic, while on the land, Argentina, Central Africa and Eastern Africa, and the islands of Indonesia, these places' temperature will rise under only 1 degree. But it's only we reached SSP 1 to 2.6 model. And then this is projected spectral patterns of change in annual average precipitation. And it shows the most part of the world will not have a change up to 10% more or less. But there are still some places that have a greater change in average precipitation. Besides the Pacific's equator, there are some places on land that will have more rainfall than usual, like the North Siberia, Central Asia, and South Arabia will have more than 10% of precipitation, and the most significantly, the Sub-Saharan Africa, where we'll have a change of more than 40% of precipitation. And then we've got these graphs. The 3 graphs in the upper part means the changes in days with the temperature greater than 35 degrees. And under the SSP 1 to 2.6 model in the future, and under the SSP 5 to 8.5 model in 2041 to 2060 and 2081 to 2100. So generally, the whole world is heating up, but there are still places that will not have more days with the temperature greater than 35 degrees, like Tibetan Plateau and the mountainous area around it, Andes, Western Europe and Northern Europe, and Madagascar. And in the lower part, it shows the change in days with NOAA heat index above 41 degrees Celsius. And also the mountainous area around Tibetan Plateau and the Andes, and the western and northern Europe, the Rocky Mountains, the northern North America and Greenland, and Alaska and north part of Russia will probably not have days with a heat index above 41 degrees Celsius. And then in the upper part of this graph, it shows the change in drought. The places like Central Africa, the southwest part of North America, the inner Arabian Peninsula, the east and south part of Australia, and the Tibetan Plateau will have fewer changes. And the lower part of the graph shows the changes in soil moisture. The more brown it gets, that means it has less moisture in the soil. So places like Southern Africa, the Amazon Basin, the Iberian Peninsula, and Mexico will have fewer moisture in the soil, while the Sub-Saharan Africa will be wetter than usual. And then the upper part of this graph talks about the changes in mean wind speed. The more green it gets, the higher the wind speed is. So in the South America to West Africa, there will be much stronger wind than usual. And on the other hand, the more blue it gets, the fewer the wind is. So in the North America, the Europe, and the Asia in general, there will be less wind in the future. And the lower part of this graph is the change in extreme total water level under different circumstances. So the extreme sea level will definitely be rising all around the world. And in the RCP 8.5 model in 2100, the extreme sea level will be about 2.8 to 1 meter larger than right now. So right now, we've come to a conclusion. The places that's the most suitable for immigration are as follows. Just by comparing all the graphs we've seen above, there are some places that will have fewer changes in the future. They are Alaska, Chile, the Central Europe and Northern Europe, the inner Arabian Peninsula, the southwest part of China, and the northeast part of Siberia. And then we've come to our final part, the future outlook. The things we did here is not done yet. Since the IPCC AR6 report doesn't provide the images above, so we can only screenshot it, and we can't have the detail of these images. And in the future, we can use GIS overlay analysis to get the results more precisely and find a place that will face the least impact. The other thing is, we only consider whether the place will be affected by the climate change. There are still a lot of things we didn't take into account. The infrastructure, electricity, water, etc. Like, are there enough air conditioners in the hot areas like in Arabia? Is the clean water supply stable in places that usually don't have a lot of water? And how can they deal with flood? The place we chose does not mean they are safe forever. Climate variables exist, and we still want to live a high quality life after all. So there are still a lot of things that can be improved in this report in the future. And that's all our final reports. Thank you.